Welcome to Saturn, the most beautiful and violent planet in our entire solar system. Saturn is famous for its magnificent rings.
Saturn is the it girl of the solar system. What is the point of an accessory if it's not visible?
Ugh, thank you, Chase.
No problem. Thank you.
He does have a point. Scientists know a lot about what happens on Saturn, but they're pretty unclear on why. For one, Saturn radiates twice as much energy into space than it receives from the sun. That means it must have an internal heat source. Do we know what that is? Absolutely not.
Oh, I bet it has something to do with the composition of the core.
Well, Chase, we're sending you to find out. Yeah, that's right. Today, Chase is falling straight into the middle of Saturn.
Oh, see that cloud pattern on Saturn's North Pole? It's like a massive swirling hurricane, like the ones you have on Earth. But this one is shaped like a hexagon.
Hexagons, rings, Saturn has every shape.
What about triangles?
Not triangles.
Rectangles?
No more talking for you.
Circles?
Saturn's cloud hexagon is huge. It's 14,500 kilometers long and 29,000 kilometers wide. That's over 6 times the width of mainland USA. That should give you a sense of just how big this entire planet is. It's the second largest in the solar system and 10 times as wide as Earth. Oops, almost forgot.
Unmute me right now! Thank you! I did not appreciate that, and you almost forgot the coolest part! A few years ago, that windstorm changed color from blue to golden. Scientists aren't really sure why, and I know why. Remember that hit internet sensation about the black and blue dress?
You mean the white and gold dress?
Literally nobody sees white and gold. Anyways, that meme got to Saturn, and Saturn's PR people wanted in.
Ugh, I shouldn't have unmuted you for that, but yeah, Saturn's northern winds are subject to pretty wild weather phenomena. Another big one, a violent storm that covers the entire planet. That's right, every 30 years, Saturn is taken over by the Great White Spot. The last one happened in 2010, so Chase should be safe to fly into Saturn. He'll have to come back in 2040 to see the Great White Spot.
Rico, mark that in my calendar, please.
Now, Saturn's most distinct feature is its huge rings. They're over 280,000 kilometers across, but only 1 kilometer thick. To the naked eye, they're practically two-dimensional.
And I'm gonna fly right through them. Of course, I could fly around them, but come on, that's like going to Paris and not seeing the pyramids. You gotta do the touristy stuff.
These rings are made up of millions of particles of ice, debris, even the remnants of dead planets. Pretty tough to navigate.
Pfft, you always doubt me, Peter.
Well, in my defense, you do die pretty often. These rings are named in order of discovery, which makes the order pretty confusing. Chase will fly through E ring and then G, F, A, B, C, D. E-ring is the furthest from Saturn, and its material is almost entirely provided by ice and water from Enceladus, a moon of this gas giant. Enceladus has a hidden ocean beneath its icy surface, and it's known for its geysers that shoot ice particles into space. These particles often get caught in Saturn's rings, making E-ring appear brighter and bigger.
And this moon is tiny. We're talking 7 times smaller than Earth's moon. But even small moons can have an enormous effect. See, Tiffany? Size doesn't matter! Whoa. That is beautiful.
It's true. Saturn's F-ring is particularly stunning. It's thin and narrow, but it's also wild and unpredictable. It doesn't look as smooth as the other rings of Saturn. That's because it's mostly made of icy particles, and these particles are being pulled by Saturn's 2 moons, Prometheus and Pandora. These moons keep the ring together, but they also mess with it. creating twists, clumps, and even braids in the ring.
That was my favorite ring so far. All right, next up, A.
The A and B rings are the two brightest rings. They're separated by the Cassini division, which is the largest gap between any of Saturn's rings. The Cassini division is over 4,800 kilometers wide, and it's likely caused by Mimas, Saturn's smallest and closest moon. Mimas has a modest radius of 200 kilometers, and it doesn't even have a fully round shape.
Some distinguished scholars say that it was the inspiration for the Death Star.
No, you are saying that. Mimas was not the inspiration for the Death Star, as the first Star Wars, Episode 4, A New Hope, it came out 3 years before the Voyager spacecraft captured detailed images of Mimas. But even this little moon is enough to disturb the particles in Saturn's A-ring and nudge them out of their orbit with its gravitational pull, creating something as vast as the Cassini division. But enjoy this gap while you can. Mimas has begun to drift away from Saturn, and without it affecting Saturn's rings, in some 40 million years, the Cassini division will close.
You know, it's awesome that the balance of orbits and moons and gravitational pulls produces something as beautiful as Saturn's rings. It really makes me think about the way that we're all a web of interconnectivity, how even small things can have an unexpectedly huge impact in people's lives.
Wow, Chase, that's really profound.
It's like that time that Rico forgot to warn me about a crater on Pluto and I fell and broke my neck. One little f***ing robot, so much trouble. Anyways, I'm about to fly through C-Ring, and I gotta be mega careful because Titan, Saturn's biggest moon, creates these gravitational tsunamis.
It's true. Titan's gravity creates a 2-kilometer wall of ice particles that orbits around the ring. Scientists call them tsunamis, but they move pretty slow, so Chase will be fine.
All right, I made it through C. Just one more ring to go, and then I'll begin my descent into the atmosphere. Check it out, I got this sick space balloon that'll help me descend into the atmosphere. Caught it for half off from the returns bin. Pretty sick.
Now, the last time a spacecraft approached Saturn, well, it didn't end well for it. The Cassini spacecraft orbited this giant for over a decade. And finally, in 2017, scientists intentionally crashed it into the planet so that it wouldn't contaminate any potential habitable moons. They literally vaporized the entire ship. The debris might even be part of these rings now.
Wow, that's really poetic, like bodies returning to the soil. Of course, none of that's gonna happen with me. Me and my clearance balloon plan on surviving this one. I peg our chances at around 80%. Oh, is that a rip? Duct tape fixes that.
Saturn is mostly hydrogen and helium, which makes Saturn the only planet less dense than water. Yeah, if you threw it into a giant lake, it would float.
Rico, read the atmospheric composition.
Calculating. 75% hydrogen and 25% helium with traces of methane and water ice.
You needed a calculation for that? What are you doing with your free time?
To get all the way to the center of Saturn, you'd have to first go through the thick gaseous atmosphere, and then through a layer of liquid hydrogen, then through metallic hydrogen, and finally reach the incredibly rocky core. Now, you'd be passing through Saturn's troposphere, and it's freezing. The temperature here is about minus 175 degrees Celsius.
Yeah, I'm feeling the chills. Okay, let's go.
Yeah, you entered the atmosphere right around Saturn's equator, which is where the winds are the fastest. not the best move. The gas planet rotates on its axis once every 10 hours and 33 minutes, which is incredibly fast for such a large planet. This speed means that Saturn actually bulges a little around its equator, like me, and concentrates jet streams in that area. Add so much heat rising from Saturn's interior, and you get high-energy winds that reach up to 1,800 kilometers per hour. That's 4 times as fast as the fastest hurricane winds on Earth. You do not want to get caught in anything like that.
Rico, slow me down!
Calculating.
Calculating? What are you calculating?
Slow down initiated.
Oh, I'm gonna be sick. Oh God. Rico, next time we're about to enter a tormenting wind place, just slow us down to begin with.
Manual override needed to activate wind countering.
Ugh, you're about as helpful as usual. Oh God, what is that smell?
You're currently in Saturn's top cloud layer, 100 kilometers below the top of Saturn's troposphere. The clouds here are almost entirely ammonia and ammonia ice, which have a notoriously bad, pungent smell. And the temperature here is about minus 250 degrees Celsius. All this ammonia in Saturn's cloud tops is what gives Saturn its yellow hue.
You know, other than the horrible smell, the freezing temperature, and Rico's inability to use a calculator, this place isn't that bad. We moved away from the equator, so the wind's a little slower. The pressure is, Rico, give me a pressure reading.
400 millibars.
That's like 40% of Earth's pressure. Honestly, I'm chilling.
After the stinky ammonia clouds comes the second cloud deck, made of ammonium hydrosulfide clouds.
Rico, another pressure read.
1.7 bars.
Oh, okay, that's not that bad. That's like just a little bit more than Earth. All right, let's keep going down.
170 kilometers below the troposphere. Temperature reading, minus 70 degrees Celsius.
Oh God, it smells even worse here. Oh God, what is going on?
Ammonia hydrosulfide detected.
Oh, great. My 2 favorite scent combos, together at last, urine and fart. Chef's kiss.
At this depth, the pressure is about 5 bars. That's like scuba diving in a depth of about 35 meters. Not pleasant, but it's not unimaginably painful either.
Oh, my sinuses are starting to burn. If I just don't use my nose, I can get through this.
As the pressure and temperature steadily increase deeper into Saturn's atmosphere, more complex compounds form. The upper layers of Saturn only have ammonia ice, but as you go deeper, you'd be surrounded by ammonium hydrosulfide. Sadly for Chase, complex compounds don't always mean better smelling ones.
Yeah, I'm still waiting for Chanel number 5 to make a planet, but it's getting a little warmer in here, so soon it'll feel like a tropical vacation.
You are 220 kilometers below the troposphere. Temperature reading, 0 degrees Celsius. Pressure reading, 10 bars.
This is Saturn's thickest cloud layer. It spans 10 kilometers and is mostly made of water ice and some ammonium droplets.
What's happening?
High pressures causing balloon deflation.
Okay. So I guess when I came up with this balloon idea, I was thinking about descending into the planet. And I forgot to think about ascending. On the way back out. Yikes.
The cloud layers and outer atmosphere are just 17% of Saturn. The other 83% is almost entirely made up of liquid hydrogen, with a relatively small rocky core at the very center. This deep into Saturn's atmosphere, the pressure is extremely high, and it's constantly increasing. All this incredible pressure does one interesting thing. It turns hydrogen gas into a liquid. So just 500 kilometers below the troposphere, the pressure is 1,000 times higher than it is on Earth.
This is really unpleasant. It's hot, It's hot and it hurts. It's hot, it's so hot, and it's a liquid, not a gas. It's hot and it's counterintuitive too.
That's just the power of 1,000 bars of pressure.
Rico, what is it, temperature? Rico, calculate temperature, please.
Calculating. 730 degrees Celsius.
Okay, and how's my balloon doing?
Heat and pressure accelerating balloon deflation.
Oh, that's not good. That's not good at all. That's not good for Chase, boy. Oh, no.
17% inflation.
Oh, man, if only real inflation rates would come down this quick, I could buy eggs again.
13% inflation.
Okay. You can stop now. Seriously, next time I'm installing a reinflate feature, or a go-up feature, or a grappling hook. Something!
0% inflation.
Huh? Ah!
Well, Chase is currently falling through 60,000 kilometers of liquid hydrogen. As he goes deeper into Saturn, the pressure will become even more unbearable. Soon, it'll get as high as 2 megabars. That's 2 million times the pressure you experience on Earth. At this point, atoms are under so much pressure that they can't maintain their shape. The pressure literally squeezes the atoms so much that their electrons create an electrically conductive layer in the planet, metallic hydrogen. This layer is 30,000 kilometers thick and surrounds Saturn's rocky core. But let's see if Chase makes it that far.
Temperature reading 5,700 degrees Celsius.
Oh, Rico, do not malfunction. If anything in this suit zaps, I'm gonna get fried. Oh, Rico, we found it. Oh, man. Okay, let's just read the composition and then get out of here, okay? The first people to see Saturn's core. This is awesome. Oh, Rico, come on, help! Rico, just get the retract. Oh, that wasn't so bad. That was just.
Well, that's it for Chase. Despite all the pressure, heat, and weirdness of liquid hydrogen, he almost reached the core of Saturn. Metallic hydrogen is an incredibly conductive layer. It's surprising that Chase lasted so long. The incredible pressure and heat this deep in Saturn's atmosphere should have turned him into a burnt lump of human coal a long time ago. Now, where should we send Chase next? How about the planet with the strongest winds? Well, that's a story for another What If.